Today we will be taking notes on Unit 2.3, Factoring with Long Division. So we already know how to factor a quadratic equation with a power of 2. We also know how to factor an equation with a power of 4 using U substitution. Well, today we're going to learn how to factor equations that have different powers ranging from 3 and higher, and have typically more than 3 terms. So this one has 4. So long division, they will always give you an equation, and usually they will always give you a factor to divide by. I went ahead and set this up like you would set up a normal division problem, where the divisor is outside the house and the dividend is inside the house, and the quotient, or our answer, is going to go on top of the house. The key to solving a long division problem is always making sure that the leading x in your factor and the leading x in the dividend are the same. Here I have x, here I have 6x cubed. So I have to ask myself, what do I need to multiply this x by to make it into a 6x cubed? So I know I should definitely multiply it by 6, because 6 times x gives me 6x. And then I also need to go from x to the power of 1 to x cubed. And we know our rules for exponents: whenever you multiply two variables with exponents, you add them together. So if I do x squared times x, that's going to give me x cubed. So I'm actually going to show my work for this out to the side. And now I have to multiply the divisor by 6x squared. So 6x squared times the divisor. Just so you know what I'm talking about, 6x squared times the divisor. And I'm going to do that over here out to the side. So 6x squared times x gives me 6x cubed. And 6x squared times negative 3 gives me negative 18x squared. So now you can see I chose 6x squared because when you multiply 6x squared by the leading x, you get 6x cubed. And we know we want 6x cubed. So now the next thing you're going to do is you're going to take all of this right here and you're going to subtract it from the dividend. Minus, and you're going to do parentheses, because remember that negative sign is going to distribute to everything inside of the parentheses. So 6x cubed negative 18x squared, close parentheses. 6x cubed minus 6x cubed. These are officially gone, which means we did this correctly, because your leading term should always disappear. So now we have negative 25x squared minus negative 18x squared. Remember, when you're subtracting a negative number, that actually means addition. So negative 25x squared plus 18x squared gives us negative 7x squared. And then, of course, I'm going to bring down the rest of the equation, giving me plus 18x plus 9. So my new leading term is negative 7x squared. So I have to figure out what I'm going to multiply x by to give me negative 7x squared. So of course I should multiply it by negative 7. And then to get my x from a exponent of 1 to a squared, I'm going to multiply it by another x. And of course, we're going to show our work off to the side. So start by multiplying negative 7x times x, giving me negative 7x squared, and negative 7x times negative 3, giving me positive 21x. And of course, we then subtract negative 7x squared plus 21x from the previous remainder. And again, I'm going to place it in parentheses because we know that negative sign is going to get distributed. So negative 7x squared minus negative 7x squared. So remember, double negative gives you a positive. So negative 7x squared plus 7x squared makes these disappear. So again, we made the right decision because the leading term disappeared. Now we have to move on. So 18x minus 21x gives us negative 3x. And of course, we're going to bring down the rest of the equation. So now my new leading term is negative 3x. So I have to ask myself, what am I going to multiply x by to make it negative 3x? Well, that one is pretty simple. We're just going to multiply by negative 3. And again, we're going to show our work off to the side. So first, I'm going to multiply negative 3 by x, giving me negative 3x, and then negative 3 by negative 3, giving me positive 9. And the final step is going to be to subtract our new equation from our previous remainder. So minus negative 3x plus 9. Now, of course, negative 3x minus negative 3x is the same thing as negative 3x plus 3x, so our leading term disappears. And then finally, 9 minus 9 is also 0. So we have reached the end of the problem, giving us our answer, or our quotient, of 6x squared minus 7x minus 3. So I do want to say one thing really quickly, that your quotient should be an equation. So if these next terms were both positive, then you would simply just put plus signs. Or if these next terms are negative, which is what they are, you just put subtraction signs. And also don't forget to match up your exponents whenever you're writing the quotient. So you always want to write them above the correct exponent. Since we didn't multiply anything by x cubed, we did not put anything above x cubed. So what we know so far is that x minus 3 is a factor of this equation, and now 6x squared minus 7x minus 3 is also a factor of this equation. So to finish this problem, we now have to factor this into smaller factors. And so I'm not going to show the steps for that because we should already know how to factor something with a power of 2. But this is going to end up factoring out to 2x minus 3 times 3x plus 1. And of course, I need to bring down my original factor. So as you can see, this polynomial right here, 6x cubed minus 25x squared plus 18x plus 9, breaks down into x minus 3, 2x minus 3, and 3x plus 1. Now, you can set these all equal to 0 so that you can find out where this equation crosses the x-intercept. But for now, all we care about is finding our factors.